So we'll be discussing discrete random variable distribution. Okay? Okay. Remember, statistics is the grammar of science. Okay? So what is probability distribution? Okay? In gathering data, it is important to understand how data was gathered. The method of gathering data results to different forms of probability distribution. Data can be gathered through, number one, repeated trials, but each trial is independent from the other. Number two, repeated trials, but the next trial depends on the previous trial. Three, success in the trials occur in a given place, in a given space. Okay, in a given space. So probability distribution, gathering of data, we can use the following. Okay, but we will be discussing only three. Okay, we will be discussing only three, and that will be binomial, hypergeometric, and then Poisson. Okay, so in gathering data, we need to discuss the three probability distribution, and that will be binomial, hypergeometric, and then Poisson. Okay, only three. So start with the first one. Any experiment whose outcomes are classified as either a success or a failure, we call that Bernoulli trials. Okay, Bernoulli trials. What is Bernoulli trials? Any experiment whose outcomes are classified as either there are only two outcomes, and that will be success or a failure. And that experiment, we call it Bernoulli trials. Okay? The probability of success, denoted by P, for each trial is constant. And then the probability of failure, denoted by 1 minus P, or denoted by Q, okay, small q, for each trial is constant. Okay? You can use 1 minus P or Q. Okay? Bernoulli distribution, a Bernoulli random variable x denoted by a random variable x implies that Bernoulli probability of Bernoulli has the probability mass function. So the probability mass function of Bernoulli trials or Bernoulli distribution is equal to the probability of success raised to x multiplied by the probability of failure, which is 1 minus P or Q raised to 1 minus x, wherein x is equal to 0 and 1. Okay, or otherwise. Then to solve for the mean of Bernoulli trials, mu sub x pertaining to the mean is equal to the probability of success. And then the standard deviation, that will be sigma sub x. Okay, sigma sub x, you're referring to the standard deviation. So that will be the square root of P multiplied by 1 minus P. Okay, 1 minus P, you're referring to the probability of failure. Okay, but how do we connect that to binomial distribution? Okay, to binomial distribution. When Bernoulli trials are performed more than once, okay, when Bernoulli trials are performed more than once, there must be a fixed number of trials and identical and independent trials. The probabilities for success and failure are still constant. Again, how do we connect that to binomial distribution? When Bernoulli trials are performed more than once, we call it binomial distribution. Okay? Binomial distribution. Again, we say Bernoulli trials, an experiment with outcomes that can be probability of success or probability of failure. But if the Bernoulli trials are performed more than once, then we call it binomial distribution. Okay? Binomial distribution, a binomial or random variable x denoted by the random variable x implies to binomial distribution has a probability mass function. Okay, this one. The probability of x is equal to n taken k multiplied by the probability of success raised to k multiplied by the probability of 1 minus p, which is probability of failure raised to n minus k, where k is equal to 0, 1, and n, meaning, and so forth. Depends on the given value. Okay? It determines the probability that there will be a k success out of n trials. Okay? Then to solve for the mean of a binomial distribution, so mean is equal to np, and then the standard deviation, that will be equal to the square root of np multiplied by 1 minus p. Okay? Another symbol, okay? Some books they use this kind of symbol, but they are the same. Okay? They are the same. So in solving for binomial distribution, we can apply this symbol also. Okay? Any of the two, it's up to you. They will come up with the same answer. Okay? So p, or the probability of x, is equal to n taken x p raised to x multiplied by q raised to n minus x. Remember that q, 1 minus p is the same as q. They are the same. 1 minus p is the same as q. When we say q, you're referring to the probability of failure. This one is failure. P, you're referring to success. Okay? Probability of p, that is success. Q, you're referring to failure. Okay? So this is another symbol in solving for binomial distribution. Okay? So p, what do you mean by p? P pertaining to the probability of success. Q, the probability of failure. Or it can be 1 minus p. So to solve for q, or to solve for the probability of failure, 1 minus p. Why is it 1 means? Because the highest value in the probability is 1. So I do have 1 minus p. Okay? Next, n. What do you mean by n? When we say n, number of trials. Okay? Number of trials. What about x? X or k? Okay? X or k? X or k? So x, you're referring to the number of successful trials. Okay? So you can use any of the two symbols. They will come up with the same. Okay? So in solving for the binomial distribution, so the probability of x is equal to n taken x multiplied by the probability of success, which is denoted by p raised to x multiplied by the q, which is a probability of failure, raised to n minus x. P stands for the probability of success. Q stands for the probability of failure, 1 minus p. N, number of trials. X, number of successful trials. Okay? So this is how we solve binomial distribution. Okay? Binomial distribution. So you can use any of the two. Okay? So binomial experiment, it's a probability experiment that satisfies the following 4 requirements. Number 1, so number 1, there must be a fixed number of trials. Number 2, each trial can have only 2 outcomes. Okay? Each trial can have only 2 outcomes. And what will be? Success and then failure. Number 3, the outcomes of each trial must be independent of one another. The outcomes of each trial must be dependent of one another. Number 4, the probability of success must remain the same for each trial. The probability of success must remain the same for each trial. So take note of the following 4 requirements in a binomial experiment. Okay? Let's proceed now to example number 1. Okay? Example number 1. So example number 1, a coin is tossed 3 times. Find the probability of getting exactly 2 heads. A coin is tossed 3 times. Find the probability of getting exactly 2 heads. Now, how do we solve this one? This one is binomial distribution because we do have 2 outcomes. And that would be probability of failure and then probability of success. So how do we apply the formula in solving this problem? Okay, first, you need to identify the given. Okay, identify the given. So in this particular example number 1, a coin is tossed 3 times. Find the probability of getting exactly 2 heads. Now, what is your n? N pertaining to the number of trials. In this example number 1, how many trials that we need to execute? That is your n, number of trials. So in this example number 1, how many number of trials we need to execute? We need to perform. Anyone? How many number of trials do we need to perform? 3. Okay, 3. Okay. So if the Bernoulli experiment perform more than once, then we call that experiment as binomial experiment or binomial distribution. It's more than once. So that's binomial distribution. Okay? But if the experiment deals with failure and success, we call that Bernoulli already. Bernoulli trials or Bernoulli experiment. But if the experiment perform more than once, that's binomial experiment or binomial distribution. So that's the connection of Bernoulli trials to binomial distribution. Okay. So the number of trials that we need to perform in this example number 1 is 3. Okay, 3. Now, x. What about x? Okay, we need to identify the number of success. Okay, we need to identify the number of success. In this particular, what is your x? What's the value of x? What's the value of x? in tossing a coin 3 times, we need to find out that what is the probability of getting exactly 2 heads. So the number of success in that particular trial is what? The number of successful trials. Okay, 2. Okay, so 2. So that will be your x. Okay, the value of x is 2. Now, so after we identify the value of n and x, we need to test. So what is the probability of getting a head? Okay, getting a head. What's the probability? In tossing a coin, what's the probability of getting a head? If you toss a coin?
1/2.
Okay, 1/2. So that is your probability of success. Now, what about Q pertaining to the probability of failure? So what is the probability of not getting a head if you toss a coin?
1/2.
Okay, 1/2 also. Okay, so 1/2 also. Now, to find the answer, just simply substitute. So the probability of getting 2 heads, okay, the probability of getting 2 heads is equal to 3 taken 2 multiplied by 1/2 raised to x, which is 2, multiplied by 1/2 raised to n minus x. So that will be 3 minus 2. So using your calculator, can you please give me the answer? So what will be the answer? Can anyone give me the answer? Using your calculator, give me the answer now. What will be the answer? What will be the answer, anyone? Just use the calculator and then give me the answer. So what will be the answer? What will be the answer? Answer? Yes? You may use your calculator to give me the answer. So what will be the answer? What will be the answer, my dear people? Anyone, what will be the answer? You just press it using the calculator. What's the answer? Your answer can be fraction or decimal. So what will be the answer? Anyone, what will be the answer? Anyone? What is the answer? The answer is what?
1.50 po.
1.50? Okay, let's do it using the calculator. Let's do it using the calculator. First, you need to press 3, and then you need to press 3, and then the combination symbol. Can you see it? Combination symbol.
This is 3/8.
Okay, 3/8. Okay, that is 3/8. 3/8. Or the equivalent of that one is? What's the equivalent of 3/8?
0.37.
Okay, 0.375. So your answer can be a fraction or a decimal. So 3/8 or 0.375. So that will be example number 1. Okay, next. Next, number 2. Next, number 2. 40% of a class is female. What is the probability that 6 of the first 10 students arriving in the classroom will be female? Okay, I repeat, example number 2. 40% of the class is female. What is the probability that 6 of the first 10 students arriving in the classroom will be female? So that will be example number 2. So before we apply the formula for binomial distribution, first we need to identify what are the given. Okay, what are the given? So we have n. When we say n, the number of trials. Number of trials. Number of trials. So in here, how many respondents? How many students? How many students in number 2?
10 po.
10. So that would be the number of trials. So 10 students. Okay? Out of 10 students, how many are female? Okay, what is the probability that the 6 of the first 10 students arriving in the classroom will be female? So n there will be 10. Okay? And your x, okay, the value of x will be 6 because we need to determine what is the probability that the first 6 out of 10 students arriving in the classroom are females? Okay, so your x, the value of your x variable is 6. Okay, so we need to determine the number of successful trials. Now, what about your probability of success? P. What is the probability that the class is female? So that is your success. In that particular problem, what is the probability that the class is female? What's the probability that the class is female?
40%.
Okay, 40%. So that will be 0.40. Now, what is the probability that it's not female? Meaning the probability of failure. So you can solve it. Since Q is equal to 1 minus P, so the probability of failure is what?
0.6 or 60%.
Okay, 60% or 0.60. Okay? 0.60, that is your failure. Okay, the probability of failure. 0.60, how do you get 0.60? 1 minus 0.40. So you do have 0.60. Can still follow?
Yes, please.
Okay, now, we can now solve using the binomial distribution formula. So that will be the probability of 6, okay, the first 6 students are females is equal to 10 taken 6 multiplied by 0.40 raised to 6 multiplied by 0.60 raised to 10 minus 6. So what is 10 minus 6? So that will be 4. So what will be the answer? What will be the answer? What will be the answer? Using the calculator, give me the answer. What will be the answer? 10 taken 6, multiplied by 0.40 raised to 6, then multiplied by 0.60 raised to 4. How do you get 4? 10 minus 6, so you do have 4. So what will be the answer?
0.52 po.
Okay. So the answer is what? The answer is? The answer is what? Can you please double check it again? 10 taken 6 multiplied by 0.40 raised to 6 multiplied by 0.60 raised to 4. Can you please check?
0.11 po.
Okay, okay, very good. Just give me the answer, 2 decimal places. So that will be 2 decimal places? Okay, very good. So that will be 0.11. Okay, 0.11. Okay, so that will be example number 2. So the answer is 0.11 or 0.1114 or 0.1115. Okay, so just give me 2 decimal places, so 0.11. Next, number 3. What about number 3 example? A machine which produces ball bearings is known to produce 5% defective items. What is the probability that a batch of 15 produced by the machine will have at least 1 defective item? Okay, so how do we answer number 3? Again, a machine which produces ball bearings is known to produce 5% defective items. What is the probability that the batch of 15 produced by the machine will have at least 1 defective item? In number 3, okay, first we need to examine the problem. We need to look for the probability that X is at least 1 defective, meaning out of 15 produced by the machine, we need to determine the probability of defective at least 1, okay, of those, at least 1. So therefore, that will be X is greater than equal to 1. Okay, greater than equal to 1. Why is it? Why is it? The probability of X greater than equal to 1. Why is it greater than equal to 1? Why? Because the problem says, okay, very good, because the problem says, what is the probability that the batch of 15 produced by the machine will have at least 1 defective? So meaning, you need to determine the probability of 1, probability of 2, up to probability of 15. So lahat yun. So from 1 to 15, you need to get its probability. If you will do that, it's really tasking, right? It's really, what do you call it? It's too long. Okay? So how do we make it short? If you want to get the probability of 1 to 15, okay, it's quite long solutions. So how can we make it simple and then short solution? Okay? So to come up with that one, so instead of getting the probability from 1 to 15, okay, from 1 to 15, we will make it simple. Okay? So the probability of X is greater than equal to 1, meaning you need to determine the probability of 15 produced machine, at least one, okay, one defective up to 15 defectives. So to solve number 3, you need to get the reverse of this one. What is the reverse of X is greater than equal to 1? What is the reverse? Anong reverse ng X is greater than equal to 1? What's the reverse of greater than equal?
Negative 1 is... Wait, okay.
Negative is not, it's not included if we're talking about probability. Remember, the smallest value is 0. So to solve number 3, it will become the probability of X less than 1. Okay, the probability of X less than 1. So we need to get the probability of less than 1, which is, what's less than 1? What's a number which is less than 1? What's a number which is less than 1? What number is that? Okay, 0. Okay, up to 0 only because the lowest value in probability is 0. So walang negative numbers, okay? Walang negative, okay? Only 0. So to solve number 3, so to solve number 3, so the probability of X greater than equal to 1, meaning, what is the probability that a batch of 15 produced by the machine will have at least one defective item? So to solve that, that will become 1 minus, okay, 1 minus the reverse of this. Okay? So instead of getting at least 1 to 15, you need to get the reverse of that 1. Yung opposite nun, which is the probability that X is less than 1. Okay? 1 minus the probability that X is less than 1. So that will become 1 minus the probability of 0. Ano ba yung number na less than 1? 0. Okay? So that will become 1 minus the probability of 0. So meaning, 15 taken 0. Okay? 15 taken 0. Multiply by, what is the probability? What is the probability that it will be defective? Okay? What is the probability that the machine will be defective? According to the problem, ano yung probability that the machine will be defective? How many percentage? It's given the problem. Okay, 5%. So that will be 0.05. Now, what is the probability na hindi defective yung machine? What is the probability?
95%.
Okay, 95%. So that will be 0.95. Okay, so just simply substitute. So 15 taken 0, multiply it by 0.05 raised to 0. Okay, multiplied by 0.95 raised to 15 minus 0. So 15 minus 0 is 15. Okay, so what will be the answer now? What will be the answer? 1 minus bracket 15 taken 0, multiplied by 0.05 raised to 0, multiplied by 0.95 raised to 15. How do you get 15? 15 minus 0. So what will be the answer? Anyone?
0.54.
Okay, let's see. Okay, the answer is 0.54. Very good. So 0.54. Okay, next, number 4. Number 4. A machine which produces ball bearings is known to produce 5%. Okay? Defective items. Similar with number 3 example. A quality control technician takes a random sample of 15 ball bearings produced by this machine and rejects the production run if at least 2 of the ball bearings is found defective. What is the probability that the batch produced by the machine will be accepted? On the average, how many defective items will be found in a sample of size 15? So in here, in number 4, we need to get the probability, okay, that the batch produced by the machine will be accepted. Okay. Remember that if it's at least 2 of the ball bearing is found defective. So how do we answer number 4? How do we answer number 4? Anyone? A machine which produces ball bearings is known to produce 5% defective items. A quality control technician takes a random sample of 15 ball bearings produced by this machine and rejects the production run if at least two, okay, if at least two of the ball bearings is found defective. So to visualize this problem, we need to determine the probability that at least two are defectives. Okay, at least two are defectives. Okay, if it's at least two, so same thing. So 2 to 15. Okay, remember the machine can be in a machine it can be 2 defectives, 3 defectives, 4 defectives, up to 15 defectives. So it's quite long. So how can we make it simple and short? How can we make it simple and short? In number 4, how can we make it simple and short? Do we need to get one by one from 2 to 15? Can you do that? Probability of 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 15? Can you do what? Can you do that? From 2 to 15? So it's quite long if you will do that. So how can we do that? How can we answer number 4? Any idea?
The number lower than 2.
Okay, so that will be 1 minus the probability, which is numbers lower than 2. So that will be x is less than 2. Okay, x less than 2. So what are those numbers? What are those numbers? X less than 0. Okay, 1 and 0. So that will be 1 minus the probability of 0 plus the probability of, the probability of 1 and the probability of 0. Okay? So 1 minus the probability of 1 plus the probability of 0. Okay? 1 minus the probability of 1 plus the probability of 0. Okay? So let's proceed now. So we have the probability of x greater than equal to 2. So that will be 1 minus, what is the probability of 1? Probability of 1, that would be 15 taken 1, multiplied, it's a continuation. So we have 0.05 raised to 1, multiplied by 0.95 raised to 15 minus 1. Okay? Next, the probability of 0, 15 taken 0, multiplied by 0.05 raised to 0, 0.95 raised to 15 minus 0. So what will be the answer? So the answer will be 1 minus, okay, the probability of 1 plus the probability of 0. So what will be the answer? What will be the answer? What will be the answer? Anybody? What's the answer? Get first each probability and then you add and subtract it. So what will be the answer? What's the answer? What's the answer? Anyone? You can get each probability and then subtract it by 1. What is the probability of 1? Anong probability ni 1? What's the probability of 1?
0.37.
Okay, 0.37. Next, probability of 0. 0.37. Sorry?
0.46.
0.46? 46?
Opo.
Okay. So therefore, what will be the answer? What will be the answer? 1 minus 0.37 plus 0.46, what will be the answer?
$1.09.
1.09. The highest value in probability is 1 only. Can you please double check again? This one is 15 minus 1. Okay, 15 minus 1. So can you please double check again? Please double check again. First, you need to get the probability of 1. So we have 15 taken 1, multiplied by 0.05 raised to 1, multiplied by 0.95 raised to 14. So that will be equal to 0.37. Okay, let's see, 0.37. Next, 15 taken 0, multiplied by 0.05 raised to 0, multiplied by 0.95 raised to 15. So that will be 0.46. Okay, 0.46. So we have 1 minus 0.37 plus 0.46. So what will be the answer? What will be the answer? Can anyone please? Anyone? What will be the answer? 15 taken 1 multiplied by 0.05 raised to 1 multiplied by 0.95 raised to 14. So the answer is 0.37. So 0.46. So 1 minus 0.37 plus 0.46. So what will be the answer?
0.17.
Okay, 0.17. 0.17. Okay, 0.17. So that will be the probability. Now, on the average, how many defective items will be found in a sample size of 15? So we need to solve for the average, meaning the mean. Okay, so how do you solve for the mean? What's the formula in solving for the mean? It's a binomial. What's the formula in solving for the mean? It's a binomial. How do you solve for the mean if it's a binomial? So that will be n multiplied by p. So n here, you're referring to the number of trials. In this particular problem, you're referring to the number of sample, which is 15. What about p? When we say p, you're referring to the probability of success. In this particular problem, what is your probability of success? What's the probability of success? In this problem, what is your P? What is your probability of success in this problem? It's already given.
5%.
Okay, 5%. So that will be 0.05. Okay, 0.05. Now, to solve for the average, just simply multiply. So 15 multiplied by 0.05. So what will be the average? How many defective items will be found in a sample of size 15? So what's the average? 15 multiplied by 0.05. So what's the average?
3/4 or 0.75.
15 times 0.05?
Yes, miss.
15 times 0.05. That will be 0.75. Okay? So that will be 0.75. Okay? So the average is 0.75 or 1. Okay? 0.75 or 1. So that will be the average of how many defective items will be found in a sample of size 15. So meaning there are only 1 defective items. Okay? So 0.75 or that will be 0.75 or that will be 1. Okay? So on the average, how many defective items will be found in a sample of size of 15? Okay? So 0.75 or that will be 1 defective item. Okay? So that is binomial distribution. Okay? So